So let's talk about compounds. A compound is a distinct substance that contains two or more elements that are combined in a definite proportion by mass or weight. All right? So that's basically what a compound is. It's a chemical combination of two or more elements that exist in fixed proportions. So compounds, of course, we learned about this before. They can be decomposed into simpler substances, that is, into simpler compounds or even elements. And that's the difference between a compound and an element. An element cannot be decomposed into simpler substances by chemical means. All right? The atoms of the element that constitute a compound are always present in simple whole number ratios. So you'll never have fractional ratios between two elements, right? So you might have a 1-to-1 ratio between two elements, or 2-to-1, or 3-to-2, 4-to-5, but you'll never have anything like a 1.5-to-1 ratio between two elements in a compound. Now, there are two types of compounds. You have molecular and ionic. Molecular compounds are basically consisting of molecules, which would be the smallest uncharged individual unit of a compound that is formed by the union of two or more atoms. And later on, we're going to learn that these atoms that are combined, they're actually held together by forces known as covalent bonds. An example of a molecule would be water. Water consists of two atoms of hydrogen and one atom of oxygen. Let me go to this representation here. And this is, of course, the model that is used to represent the water molecule. If you break this down, then what you're going to find is that this will be destroyed, and you're going to end up with hydrogen and oxygen being formed. So that's basically molecular compounds. Now, ionic compounds are formed by species which are known as ions. And ions are basically positively or negatively charged atoms or groups of atoms. The cation is known as the positively charged ion. An example of this would be the sodium ion. And an anion is a negatively charged ion, such as the chloride ion. All right? So when these come together, they form an ionic compound, which is basically the result of attractive forces, very strong attractive forces between the negatively charged and the positively charged ion. So sodium chloride is an example of such a compound. It's a colorless crystalline ionic substance. It consists of 39.3% sodium and 6.7% chlorine by mass. Even though they consist of charged particles, the solid state does not conduct electricity. However, if you melt it, right, then what you'll find is that you're able to pass an electric current through it, and that will result in the electrolysis of sodium chloride to form sodium metal and gaseous chlorine. Now, in terms of how the particles are arranged, basically, as I said before, there's an attractive force that exists between these ions. So sodium is positively charged, the chloride is negatively charged. You have the attractive force between them. But ultimately, what you're going to find is that they will arrange themselves in an arrangement which looks like what you see on the screen, right? You're going to see a regular repeat unit of sodium and chloride ions, and we call this a crystal structure or a crystalline structure of sodium chloride. And this is a common feature of ionic compounds. What you'll see is that they will assemble themselves into a regular ordered structure such that you can actually observe a repeat unit that exists throughout the gross structure of this particular compound. Now, we can determine the formulas for ionic compounds based on the ratio of the ions that are present in the compound, right? Because as stated here, in ionic compounds such as sodium chloride, they consist of large aggregates of cations and anions. So the best way to represent their composition is to look at the smallest whole number ratio that exists between the cations and the anions. In other words, we look at their empirical formula. Now, please note, and this is true for every ionic compound, there's no such thing as a molecule of an ionic compound, all right? We talked about molecular compounds before, and we talked about the fact that molecules are basically discrete units, which is a collection of atoms that are held together by covalent bonds. that do not exist in the case of ionic compounds. All right? So when you see a formula such as NaCl, that does not mean that there's a molecule of NaCl. What this tells you is that there is a 1-to-1 ratio between the sodium ion and the chloride ion in this particular compound. So the formula that exists for an ionic compound is actually the empirical formula for that compound. All right? So as shown here, when you look at a repeat unit such as what you see here, if you count up all the sodium ions and all the chloride ions, I won't go through that now, but you can do that on your own. What you're going to find is that there's a 1-to-1 ratio between the sodium and the chloride ions. All right? So everywhere throughout this unit cell, you're going to see a 1-to-1 ratio between the sodium and chloride ions. All right? So to briefly review what we have covered, we talked about compounds, the fact that compounds are substances that can be broken down into simpler substances by chemical means, and compounds can be subdivided into two categories. You have molecular compounds and ionic compounds. Molecular compounds are basically consist of molecules which are made up of two or more atoms of different elements that are held together by covalent bonds to form discrete units. So those are molecules. And then as far as ionic compounds are concerned, they are formed as a result of the combination of cations, which are positively charged, combining with anions which are negatively charged. All right? So that's basically what we discussed so far as compounds are concerned. Now let's talk about chemical formulas. Chemical formulas serve as abbreviations for the names of compounds. So instead of writing the actual name in words, we can simply abbreviate it, make things a bit easier by writing down the formulas, right? So these formulas tells you something about the composition of the substance that you're talking about. So for example, calcium chloride, the formula is shown here, CaCl2, all right? Now, one of the things that the formula tells you is the composition in terms of what is present, right? So CaCl2 tells you that this compound consists of the two elements calcium and chlorine, all right? It also tells you the ratio of the atoms or ions that are present in the particular compound. So for example, in this compound, the ratio of calcium ions to chloride ions is 1-to-2, all right? So that's basically what this tells you, the 1-to-2 ratio between the calcium ions and the chloride ions, all right? So let's talk about the rules for writing chemical formulas. It says here, when a formula contains one atom of an element, the symbol of that element represents the one atom, right? So the number 1 is not used as a subscript. So basically what this is saying is that if you have a chemical formula and there's no number beside it in terms of one particular element, then you can assume that that number is 1 for that particular element, all right? So for example, in this formula here, we have NaCl. There's no number indicated down here as subscripts for both sodium and chlorine. So therefore you can conclude that there's one sodium ion for every one chloride ion that is present, right? So that's how you interpret this formula. Now, this is a simple example. We can move on to one that is more complex, where you have different numbers written as subscripts for each of the different elements present. So here is an example. What this tells you is that there are 3 hydrogen atoms, 1 phosphorus atom, and 4 oxygen atoms present per molecule of this particular compound, all right? So that's how you interpret formulas. So these subscripts gives you an indication as to the number of atoms present per molecule, if it's a molecular compound, or it gives you an idea as to the ratio between the different atoms present or ions present in an ionic compound. Okay, here is another example. And in this example, it's even more complicated because in some formulas, you might find where the way it's represented, you have parentheses around a particular group of atoms with a subscript outside of it. And one example of this is shown here, right? So this indicates that you have barium, and the subscript here indicates that you have 3 barium atoms, or ions in this case. Now, when you get to this part here, right, we call this the phosphate ion or phosphate group, all right, PO4. And you'll notice that it's placed within parentheses and there's a subscript of a 2 outside. Now, each phosphate unit consists of 1 phosphorus atom and 4 oxygen atoms, right? But because you have the parentheses around it, and then you have the 2 outside as a subscript, then this 2 indicates that there are 2 phosphate groups present in this particular formula. All right, so you're going to see more of this as well. In fact, we're going to learn how to determine the ionic formula or the formula for an ionic compound based on the name and vice versa. And you're going to see in some cases where you'll need to do this, where you need to put parentheses around a group of atoms and then put the subscript indicating the number of those groups present in the formula. All right. Okay, now it says here that formula is written as H2O, H2SO4, calcium nitrate, and this compound, which is sucrose, shows you only the number and kind of each atom contained in the compound. What they do not show is how the atoms are arranged or how they are chemically bonded to each other. So what this is talking about here is a limitation of these representations. They tell you nothing about how the atoms are connected to each other in detail. They only tell you about the composition. All right, so in order for us to know about how the atoms are arranged, we have to look at other structures, other representations, which we're going to get into much later in this course. But for now, you need to recognize that these formulas only tell you what the compositions are. Okay, so that's basically the end of chapter 4. So the next video we'll be starting with chapter 5. Until next time.